August 7, 1942. Henderson Field, Guadalcanal. The air hung thick with tropical humidity and aviation fuel vapors, a metallic taste that clung to every breath. In the pre-dawn darkness, Lieutenant Jack Cram pressed his palm against the corrugated steel wall of America's newest battlefield innovation, a structure the enemy had dismissed as a death trap. The curved metal was cooled, beaded with condensation that caught the pale moonlight filtering through the jungle canopy. Around him, the sounds of war preparation echoed across the muddy airstrip, Wildcat engines coughing to life, the rhythmic hammering of mechanics, and the distant rumble of waves against the coral shore. This was the edge of the world, where American engineering would face its most brutal examination. The curved steel walls of the Quonset hut stretched away into shadows, creating a cathedral of corrugated metal that housed the tools of survival, radio equipment, ammunition stores, and the skilled hands that kept America's fighters airborne. Outside, palm trees swayed in the humid breeze, their fronds rustling like whispered prayers. The temperature never dropped below 80 degrees, even in the darkest hours before dawn. Steam rose from the jungle floor, mixing the scent of rotting vegetation with the sharp tang of metal and machine oil. Every surface was slick with moisture, the leather of flight jackets, the grips of rifles, the metal control panels that connected this remote outpost to the wider war raging across the Pacific. In radio intercepts captured just days earlier, Japanese intelligence officers had shared their assessment of America's new prefabricated shelters with unconcealed amusement. Steel ovens in the jungle, they called them in decoded transmissions. The Americans will cook themselves before we need to bomb them. The mockery was not without logic. Metal structures under the equatorial sun seemed designed for torture rather than protection. Japanese military architects, trained in wood and bamboo construction, adapted to tropical climates, viewed the American reliance on industrial materials as evidence of cultural blindness. They believed these foreign invaders would be defeated, not by bullets, but by their own arrogance in attempting to impose northern manufacturing solutions on southern Pacific realities. The laughter in Tokyo's war rooms was shared by field commanders who had witnessed the swift collapse of Western colonial defenses throughout Southeast Asia. British, Dutch, and French positions had crumbled with surprising ease, their European military infrastructure proving inadequate against Japanese tactical flexibility and tropical conditions. The Americans, they reasoned, would fare no better with their rigid industrial approach to warfare. Intelligence reports described the Quonset huts as portable furnaces that would bake their occupants into submission. Japanese pilots preparing for night bombing raids over Henderson Field were told to expect minimal resistance from defenders already weakened by their own shelters. This contempt was rooted in Japan's early Pacific victories, where superior tactics and equipment had overwhelmed seemingly modern defenses. The Zero fighter had dominated Allied aircraft through superior maneuverability and range. Japanese naval aviation had struck with precision and devastating effect at Pearl Harbor, demonstrating the vulnerability of American military installations. The conquest of the Philippines, Dutch East Indies, and Singapore had revealed the apparent brittleness of Western military engineering when confronted with Japanese innovation and determination. Each victory reinforced the belief that American industrial might was no match for Japanese tactical superiority and adaptation to Pacific conditions. The Quonset hut represented everything Japanese strategists believed was wrong with American military thinking. Standardized, mass-produced, inflexible solutions imposed without regard for local conditions or tactical requirements. These curved metal shells, they assumed, would trap their occupants in superheated chambers, forcing evacuation or surrender without requiring ammunition expenditure. The very name seemed to confirm American detachment from battlefield reality. Quonset, derived from the Algonquian word meaning long place, suggested structures designed for North American conditions rather than tropical warfare. Yet the steel that Japanese intelligence dismissed carried within its molecular structure the accumulated knowledge of American metallurgy and industrial engineering. Each corrugated sheet bore the imprint of Pennsylvania steel mills, where immigrant workers had perfected techniques for creating metal that could withstand temperature extremes, corrosion, and mechanical stress. The galvanized coating that protected each panel represented decades of chemical research into preventing rust and deterioration in maritime environments. The curved design, seemingly arbitrary to Japanese observers, incorporated principles of structural engineering that distributed stress loads and maximized interior space while minimizing material requirements. The Quonset hut had emerged from the urgent improvisation of wartime production, designed by the Navy's Bureau of Yards and Docks to solve the massive logistical challenge of housing American forces across the globe. Named after its development site at Quonset Point Naval Air Station in Rhode Island, the structure represented a marriage of architectural innovation and manufacturing efficiency. The design team, led by engineer Peter Detweiler and architect Dimitri Commandant, had studied British Nissen huts while incorporating American mass production techniques and materials science advances. The specifications were deceptively simple: 16 feet wide, varying lengths up to 60 feet, constructed from 22-gauge galvanized steel sheets formed into corrugated arches. Each structure could be manufactured in sections at American factories, shipped worldwide in compact bundles, and assembled by untrained crews using only basic tools. The curved arch design eliminated the need for internal support beams, maximizing usable interior space while creating structures capable of withstanding hurricane-force winds and seismic activity. Most critically for Pacific deployment, the galvanized coating and steel construction resisted the corrosive effects of salt air and tropical humidity that destroyed wood and canvas alternatives within months. Production had begun in earnest during 1941, with factories across the American industrial belt retooling to manufacture the standardized components. By the time of Pearl Harbor, weekly production exceeded 1,000 units, with the capacity for rapid expansion as military requirements intensified. Each hut incorporated lessons learned from earlier prefabricated designs, including improved ventilation systems, standardized door and window opening, and modular construction techniques that allowed structures to be extended or modified in the field. The steel came primarily from mills in Pittsburgh, Gary, and Birmingham, where new furnaces operated continuously to meet military demands. The engineering philosophy behind the Quonset hut reflected broader American approaches to industrial warfare: standardization, mass production, and systematic problem-solving applied to military logistics. Unlike traditional military construction, which required skilled craftsmen and locally sourced materials, these structures could be manufactured by semi-skilled workers using assembly line techniques, then deployed anywhere American forces operated. Each hut was essentially identical, allowing for interchangeable parts, standardized repair procedures, and predictable performance characteristics, regardless of location or climate. Quality control procedures ensured that every steel sheet met precise specifications for thickness, corrosion resistance, and structural integrity. Testing protocols subjected sample structures to simulated combat conditions, including explosive concussion, projectile impact, and extreme temperature variation. The results consistently demonstrated the superior durability of steel construction compared to canvas, wood, or concrete alternatives in rapid deployment scenarios. Most significantly for Pacific operations, the structures proved resistant to termite damage, fungal decay, and the corrosive effects of constant humidity that plagued traditional building material. The first Quonset huts had arrived at Henderson Field aboard transport ships during the initial American landing on August 7, 1942. Within hours of hitting the beach, construction crews were assembling the curved metal sections using techniques refined during training exercises in the United States. Each structure required only basic hand tools, wrenches, screwdrivers, and hammers, eliminating the need for heavy construction equipment that would be vulnerable to enemy attack. 6 men could complete assembly in under 8 hours, creating weatherproof shelter capable of protecting personnel and equipment from tropical storms and enemy action. The strategic importance of Henderson Field made rapid construction essential. This captured Japanese airstrip represented the most forward American position in the Solomon Islands, a critical base for interdicting Japanese supply lines and supporting further advances toward Japan itself. Every day of delay in establishing permanent facilities increased vulnerability to Japanese counterattack and reduced the operational effectiveness of American forces. Traditional construction methods would require weeks or months to create adequate shelter and storage facilities, time that simply did not exist in the fluid tactical situation surrounding Guadalcanal. Combat engineers worked around the clock to establish defensive positions, while simultaneously building the infrastructure necessary for sustained air operations. The Quonset huts served multiple critical functions: housing for aircrew and maintenance personnel, storage for ammunition and spare parts, communications centers for coordinating operations, and medical facilities for treating casualties. Each structure represented not just shelter, but operational capability that directly translated into combat effectiveness and mission success. The Japanese High Command had anticipated that American forces on Guadalcanal would require extensive time and resources to establish effective operations from Henderson Field. Intelligence estimates suggested that tropical conditions, combined with continuous Japanese air and naval attacks, would prevent the Americans from creating sustainable defensive positions. The assumption was that hastily constructed facilities would prove inadequate under combat pressure, forcing evacuation or surrender within weeks of the initial landing. August 23, 1942, 23:40 hours. The night air filled with the drone of approaching aircraft engines, a sound that had become terrifyingly familiar to the defenders of Henderson Field. Lieutenant Cram pressed himself against the steel wall of the radio hut, feeling the vibrations of 24 Mitsubishi G4M Betty bombers approaching from the northwest. The aircraft had lifted off from Rabaul 3 hours earlier, loaded with high explosive and incendiary bombs intended to destroy the American airfield and its supporting facilities. Air raid sirens wailed across the base as personnel dove for cover in trenches, bunkers, and whatever shelter they could find. The Japanese had perfected these night bombing tactics, using darkness to avoid American fighter interception while delivering precision strikes against critical targets. Previous raids had demonstrated their ability to hit fuel dumps, aircraft parking areas, and command facilities with devastating accuracy. Tonight's attack promised to be the largest yet, designed to eliminate Henderson Field as an operational threat once and for all. The first bombs fell with the characteristic whistle of descending high explosives, followed by earth-shaking detonations that lit the jungle with orange flashes. A fuel storage tank erupted in a pillar of flame that climbed toward the stars, casting dancing shadows across the airfield. The ground trembled beneath the impact of 500-pound bombs, each explosion sending shockwaves through the coral soil that formed the foundation of the American position. Inside the Quonset huts, personnel braced themselves against the corrugated walls as the bombardment intensified. The radio hut shook with each nearby impact, dust cascading from the curved ceiling as equipment rattled on metal shelving. Outside, the sounds of destruction merged into a continuous roar: exploding ordnance, collapsing structures, screaming engines, and the crackle of spreading fires. The air itself seemed to burn, thick with smoke and the acrid smell of high explosives and aviation fuel. Lieutenant Cram clutched his radio headset, maintaining contact with surviving units scattered across the base. Static filled the airwaves as antenna systems suffered damage from bomb fragments and concussion effects. Through the interference, he could hear reports of direct hits on aircraft parking areas, the ammunition dump, and several administrative buildings. The scale of destruction was unlike anything previously experienced at Henderson Field, suggesting that Japanese intelligence had identified critical vulnerabilities in American defensive preparations. A particularly massive explosion shook the radio hut, with enough force to crack the concrete floor pad beneath the steel structure. The blast had destroyed a fuel truck parked less than 50 yards away, sending burning gasoline cascading across the muddy ground between the Quonset huts. Fragments of metal and wood peppered the corrugated walls with sharp metallic impacts, each hit sounding like rifle shots in the enclosed space. The bombardment continued for what seemed like hours, but lasted only 23 minutes according to the mission logs recovered after the war. When the drone of aircraft engines finally faded into the distance, an eerie silence settled over Henderson Field, broken only by the crackle of burning fuel and the groans of damaged structures settling under their own weight. Smoke obscured the moon and stars, creating an artificial dawn of orange flames reflected against low-hanging clouds. Lieutenant Cram emerged from the radio hut, expecting to find devastation comparable to previous Japanese air raids against American positions throughout the Pacific. The attack had been more intense and sustained than anything previously experienced on Guadalcanal, suggesting a major escalation in Japanese efforts to retake Henderson Field. Previous raids had typically lasted only minutes and involved smaller numbers of aircraft, but tonight's assault represented a commitment to destroying American capabilities through sustained bombardment. The scene that greeted him defied expectations shaped by months of warfare in the Pacific Theater. Where canvas tents had stood before the raid, only charred debris remained scattered across the muddy ground. Several wooden structures had been reduced to smoking ruins, their frames collapsed under the impact of near misses or the heat of burning fuel. Aircraft parking areas showed clear evidence of bomb damage, with several craters marking direct hits on critical facilities. But the Quonset huts stood essentially intact, Blackened by smoke and peppered with fragment damage, the curved steel structures had weathered the bombardment with remarkable resilience. Doors hung askew from damaged hinges, windows showed spiderweb patterns of cracked glass, and the corrugated walls bore the scars of shrapnel impact, but the basic structural integrity remained uncompromised. Most critically, the personnel and equipment sheltered inside had survived the most intense Japanese air attack, yet mounted against American position. Cram pushed open the door to the communications hut, expecting to find devastation inside. Instead, he discovered that while dust and debris covered every surface, the radio equipment remained operational. The steel walls had protected critical electronics from both blast effects and fragment damage that would have destroyed equipment housed in less robust structure. Within minutes, he was able to re-establish contact with higher headquarters and coordinate the American response to the Japanese attack. This unexpected survival under extreme combat conditions represented a fundamental validation of American engineering approaches to military construction. The mass-produced, standardized structures that Japanese intelligence had dismissed as inadequate had proven superior to traditional building methods under actual battlefield conditions. The galvanized steel construction had withstood temperatures, pressures, and impacts that would have destroyed wood, canvas, or even masonry alternatives. The psychological impact of this survival was as significant as the practical benefits. American personnel who had expected to find themselves homeless and defenseless after such an intense bombardment instead discovered that their industrial civilization had provided them with effective protection. The Quonset huts became symbols of American technological superiority and industrial capacity, tangible proof that mass production techniques could create military advantages unavailable to enemies, relying on traditional craftsmanship and individual skill. Word of the Henderson Field bombardment and the remarkable survival of the Quonset hut spread rapidly through American military channels. Engineering officers throughout the Pacific Theater requested detailed reports on structural damage and performance characteristics under combat conditions. The data collected became the foundation for improved designs and deployment strategy that would enhance American capabilities in subsequent operations. Within 72 hours of the bombardment, construction crews were erecting additional Quonset huts to replace the canvas and wooden structures destroyed in the Japanese attack. The experience had demonstrated not only the superior protection offered by steel construction, but also the rapid replacement capability inherent in standardized, prefabricated building systems. Where traditional construction would require weeks to rebuild damaged facilities, the modular design of Quonset huts allowed complete reconstruction in a matter of days. The speed of reconstruction sent a powerful message to both American forces and Japanese observers monitoring Henderson Field through aerial reconnaissance. Rather than weakening American capabilities, the bombardment had actually accelerated the transformation of Henderson Field into a more formidable and resilient military installation. Each destroyed tent or wooden building was replaced by a steel structure better able to withstand future attacks. American aircrew and ground personnel began requesting assignment to Quonset hut facilities, recognizing the superior protection they offered compared to alternative accommodations. The structures became symbols of safety and permanence in an environment where most military installations felt temporary and vulnerable. Personnel began personalizing their steel shelters, adding homemade furnishings and decorations that reflected confidence in their ability to survive and continue operations despite enemy pressure. The engineering success at Henderson Field validated the broader American approach to industrial warfare that was transforming military operations throughout the world. Mass production techniques that had revolutionized civilian manufacturing were proving equally effective in military applications, creating standardized solutions that could be deployed rapidly and maintained efficiently across global theaters of operation. Japanese intelligence officers analyzing reconnaissance photographs of Henderson Field after the August bombardment struggled to explain the apparent ineffectiveness of their most intensive air attack. Expected damage to American facilities had not materialized, and the pace of reconstruction far exceeded projections based on previous experience against Western military installations. The steel structures that had been dismissed as inappropriate for tropical warfare were proving remarkably resilient and adaptable to combat conditions. Reports reaching Japanese headquarters described American construction activities that defied conventional military engineering practices. Rather than rebuilding with locally sourced materials and traditional techniques, the Americans were rapidly erecting identical metal structures using standardized components and assembly procedures. This industrial approach to military construction suggested reserves of manufacturing capacity and organizational efficiency that posed strategic threats beyond immediate tactical considerations. The failure to suppress Henderson Field operations despite intensive bombardment forced Japanese planners to reconsider their assumptions about American military capabilities. The industrial infrastructure that supported rapid deployment and replacement of military facilities indicated a level of logistical sophistication that could potentially sustain extended operations far from American home bases. This realization marked the beginning of a fundamental reassessment of Japanese strategic options in the Pacific Theater. By September 1942, Henderson Field housed more than 50 Quonset huts providing shelter and workspace for the expanded American presence on Guadalcanal. Each structure served specialized functions optimized for specific operational requirements: radio communications, aircraft maintenance, ammunition storage, medical treatment, personnel housing, and command operations. The modular design allowed for rapid reconfiguration as tactical situations evolved and mission requirements changed. The standardization of construction materials and assembly techniques created efficiencies that multiplied American capability compared to traditional military engineering approaches. Maintenance personnel familiar with one Quonset hut could service any other structure using identical parts and procedures. This interchangeability reduced training requirements, simplified logistics, and increased the reliability of critical systems operating under combat conditions. American industrial production responded to Pacific Theater demand by expanding Quonset hut manufacturing capacity throughout 1942 and 1940. Factories in Pennsylvania, Ohio, Michigan, and California retooled production lines to meet military specifications while maintaining quality control standards that ensured consistent performance across thousands of individual units. The steel industry allocated increasing percentages of output to military construction, prioritizing galvanized sheets for overseas deployment. Quality assurance programs subjected each batch of Quonset hut components to rigorous testing procedures that simulated combat conditions and tropical environments. Materials testing laboratories evaluated corrosion resistance, structural integrity, and thermal performance under extreme conditions. These systematic approaches to quality control ensured that structures deployed to combat zones would perform reliably despite harsh environmental conditions and enemy action. The logistics of transporting thousands of Quonset huts across the Pacific Ocean required innovations in packaging, loading, and shipping procedures. Each structure was designed to pack efficiently in standardized shipping containers that maximized cargo capacity while protecting components from damage during transoceanic transport. Specialized loading equipment and procedures reduced port handling time and minimized vulnerability to enemy interdiction of supply lines. Training programs prepared construction personnel for rapid assembly under combat conditions, emphasizing speed and accuracy while working under pressure. Construction crews practiced assembly procedures until they could complete structures in minimal time using only hand tools and basic equipment. This training proved essential when construction had to continue despite enemy air raids, artillery bombardment, and the constant threat of ground attack. The success of Quonset huts at Henderson Field influenced American military construction throughout the Pacific Theater and beyond. Similar structures were deployed to support operations in Alaska, Australia, India, and eventually Europe, as American forces expanded globally. Each deployment provided additional data on performance characteristics and suggested improvements for subsequent production runs. Engineering officers submitted detailed reports on structural modifications that would enhance performance under specific environmental or tactical conditions. These recommendations led to variants optimized for different climates, terrains, and military functions. The basic design remained standardized to preserve manufacturing and logistical advantages while incorporating improvements suggested by combat experience. When reports of the Henderson Field bombardment reached engineering offices in Rhode Island, the initial reaction was disbelief, followed by intense interest in the performance data. Project engineers who had designed the Quonset hut primarily as economical temporary shelter were surprised to learn that their creation had withstood intensive combat conditions that destroyed alternative structures. The survival of personnel and equipment inside the steel buildings validated design principles while suggesting opportunities for further improvement. The engineering team, led by Peter Detweiler, conducted detailed analysis of damage reports and reconnaissance photographs to understand exactly how the structures had performed under extreme stress. The corrugated steel construction had distributed impact forces across the entire structure, rather than concentrating stress at specific points, preventing catastrophic failure even when subjected to nearby explosions. The arch design had proven particularly effective at deflecting blast pressure and fragment impact. Materials analysis revealed that the galvanized coating had provided crucial protection against both corrosion and thermal damage from burning fuel and explosive flash. Steel sheets that had been scorched black by intense heat showed no significant structural degradation, while the zinc coating continued to protect against rust despite surface damage. This performance exceeded laboratory predictions and suggested that the structures might have even greater durability than originally designed. The modular construction approach that had been intended primarily to simplify manufacturing and assembly proved to have significant advantages for battlefield repair and modification. Damaged sections could be replaced individually without requiring reconstruction of entire structures, allowing rapid restoration of functionality even after direct hits by bomb fragments or small caliber projectiles. This repairability multiplied the effective service life of structures operating under combat conditions. Production capacity expanded rapidly as military demand increased throughout 1942 and 1943. New manufacturing facilities were established in regions with available steel supplies and transportation access to seaports serving Pacific operations. Employment in Quonset hut production provided opportunities for workers previously excluded from defense industries, including women and minorities, who contributed essential skills to wartime manufacturing. The industrial mobilization required for Quonset hut production exemplified broader American advantages in manufacturing capacity and technological innovation. While Japanese forces relied primarily on locally sourced construction materials and traditional building techniques, American troops were supported by an industrial infrastructure capable of mass-producing standardized solutions to military engineering challenges. This disparity in industrial capability would prove decisive in determining the ultimate outcome of the Pacific War. Research and development programs explored advanced materials and construction techniques that could further enhance the performance of prefabricated military structures. Aluminum alloys offered weight savings for air-transported construction, while improved steel treatments promised greater corrosion resistance in maritime environments. Insulation materials and ventilation systems addressed thermal comfort issues in extreme climates without compromising structural integrity or rapid assembly requirements. The success of American military construction programs demonstrated the strategic value of industrial infrastructure that could adapt civilian manufacturing techniques to military requirements. The same factory, workers, and supply chains that produce consumer goods in peacetime could be rapidly converted to support global military operations. This flexibility provided sustainable advantages that enemy nations lacking comparable industrial capacity could not match through tactical innovation alone. By November 1942, Henderson Field had been transformed from a hastily captured Japanese airstrip into a major American military installation centered on more than 100 Quonset huts. The steel structures housed everything from radar equipment and aircraft to surgical suites and communications. Each building represented not just shelter, but operational capability that directly supported American control of the surrounding sea and airspace. The psychological transformation was equally significant. American personnel who had initially viewed their assignment to Guadalcanal as a desperate defensive mission began to see Henderson Field as a permanent base for offensive operations against Japanese positions throughout the Solomon Islands. The solid steel structures symbolized American determination to remain and expand rather than merely survive until reinforcement or evacuation became possible. Combat effectiveness increased substantially as personnel and equipment were protected from both enemy action and environmental hazards that had previously degraded operational readiness. Aircraft maintenance could continue despite tropical storms and humidity that had grounded planes when work had to be conducted in canvas shelters or open air. Communications equipment functioned reliably in climate-controlled environments that prevented the corrosion and condensation problems that plagued electronic systems housed in temporary structures. The strategic implications extended beyond immediate tactical advantages. Japanese reconnaissance flights over Henderson Field revealed an American installation that was growing stronger rather than weaker, despite continuous pressure. Intelligence reports described construction activities that suggested long-term American intentions to maintain and expand their presence in the Solomon Islands. This evidence of American commitment to sustained operations forced Japanese planners to allocate additional resources to containment efforts that diverted strength from other strategic priorities. The Battle of Guadalcanal ultimately concluded with Japanese evacuation in February 1943, marking the first major defeat of Japanese ground forces in the Pacific War. While multiple factors contributed to this outcome, the superior infrastructure that supported American operations played a crucial role in sustaining the extended campaign required for victory. The Quonset huts that had been mocked as inappropriate for tropical warfare had proven essential to American success in establishing permanent presence in the forward Pacific. Japanese after-action reports acknowledged the unexpected effectiveness of American military construction technique while attempting to explain the failure to suppress Henderson Field operations despite intensive air and naval bombardment. The standardized, mass-produced structures had demonstrated resilience characteristics that exceeded intelligence estimates based on traditional approaches to military engineering. This recognition led to efforts to develop Japanese equivalents, but manufacturing limitations and resource constraints prevented effective implementation before the war's end. The lessons learned from Quonset hut performance at Henderson Field influenced post-war military construction throughout the world. The principles of standardization, modularity, and rapid deployment became fundamental elements of military engineering doctrine for American and Allied forces. Modern military installations continue to employ prefabricated construction techniques that trace their origins to the corrugated steel building that survived the night bombardment of August 23, 1942. Veterans of the Guadalcanal campaign carried memories of those steel shelters throughout their lives, often describing the distinctive sound of rain on corrugated metal as the soundtrack of survival. Many returned home with deep appreciation for the industrial infrastructure that had supported them in combat, understanding that victory had depended not only on individual courage, but on the collective capabilities of American manufacturing and engineering. The Quonset huts themselves outlasted the military units that had first occupied them on Henderson Field. As American forces advanced toward Japan, many structures were converted to civilian use by local populations, serving as schools, churches, workshops, and homes. The durability that had proven essential under combat continued to provide value in peacetime application, creating lasting benefits from wartime innovations. Decades later, historians studying the Pacific War would identify the industrial mobilization that produced millions of tons of military construction material as one of the decisive factors in American victory. The same manufacturing capacity that supplied Quonset huts to Henderson Field also produced the ships, aircraft, vehicles, and weapons that ultimately overwhelmed Japanese resistance. The steel buildings that survived one night of hell represented the broader triumph of industrial democracy over military authoritarianism. In engineering schools and military academies, the Henderson Field bombardment became a case study in the interaction between materials science, structural design, and battlefield performance. Students learned how systematic approaches to problem solving and quality control could create solutions that exceeded the expectations of both designers and users. The curved corrugated steel that had seemed so simple proved to embody sophisticated understanding of stress distribution, materials properties, and manufacturing efficiency. The strategic significance of Henderson Field and its Quonset huts extended far beyond the immediate tactical situation on Guadalcanal. The successful defense and expansion of American facilities demonstrated industrial capabilities that enabled global military operations sustained over multiple years. This demonstration of American manufacturing capacity influenced strategic calculations in both Allied and enemy capital, contributing to decisions that shaped the ultimate outcome of World War II. When the last American forces departed Henderson Field after the war's end, they left behind steel structures that would continue serving local communities for generations. The corrugated metal that had sheltered American servicemen during their darkest hours in the Pacific became building material for schools where local children learned about the world beyond their island home. The same steel that had withstood Japanese bombardment now protected teachers and students, continuing its mission of preserving what was most valuable for the future. The mockery that had greeted American steel construction in Japanese intelligence reports became recognition of industrial superiority that could not be matched by traditional craftsmanship alone. The huts that were supposed to cook their occupants had instead provided sanctuary when everything else burned. In the end, the steel had not merely survived, it had prevailed, carrying within its corrugated curves the promise that American industrial might would ultimately reshape the Pacific and the world. History isn't just written, it's remembered through those who still care to listen. What story should we tell next? Subscribe to keep their memory alive. Your feedback is incredibly valuable and helps me keep making better content for you.